All right, we're going to go ahead. We're going to do a simple example using Green's theorem. So we're going to calculate the loop integral over a curve xy dx plus x squared dy, where our curve is the rectangle with vertices 0, 0, 3, 0, 3, 1, and 0, 1. Okay, so let's draw that real quick. So 0, 0 is here. Three, 0 is here. 3, 1 is here. 0, 1 is there. And then it's just going to be this rectangle. And when we're using Green's theorem, we're just going to assume things are going counterclockwise around it. Okay, if it was clockwise, it would just go the opposite direction. We're going to split this up. We're going to, just like before, we're going to split this up into 3 or 4 different curves. Okay, so gamma 1 is given by, well, you're going to have x is t, y is 0. Now just keep in mind that here I'm going to let t go from 0 to 3 so that I can get all the way over here. Okay. Nope. Gamma 2 is going to be 3, t, where t goes from 0 to 1. Okay, that means we're just going up this way. Okay, next way we're going to come this way back. So I'm going to say gamma 3 is going to be, let's take 3 minus t, 1. T goes from 0 to 3. Okay, finally, gamma 4 is going to be 0, 1 minus t, and t going from 0 to 1. Okay, so what we're going to do, I'm going to do it both ways in this problem, just because it's going to give us an understanding of what this theorem really is saying. But we don't really need to do it both ways. Okay, so let's do it first, you doing the line integral. I don't know why this was down in the middle of the page. So line integral first. In fact, if we do it this other way, we're not even going to need to do what we did there. Okay, so we have xy dx plus x squared dy. So we're going to take it first, gamma 1. Gamma 1, t goes from 0 to 3. So the integral from 0 to 3, but now it's x times y. X times y is going to be t times 0, and dx is dt. Plus 3 squared times 0. Right? Let's put them both in there. Okay, so this is x times y. The dx has a 1 dt. This is y, and then dy is 0 dt. Okay, so this is the integral for gamma 1, which is clearly going to be 0. All right. Plus, let's do the integral for gamma 2 from 0 to 1. Okay, we're going to do from 0 to 1, because we're doing from 0 to 1. X times y is 3 times t, but the dx is going to have a 0 in it, right? So that's going to have a 0 plus, now here we're going to have y squared is t squared, and that's going to have a dy, so we're going to have a dt there. Okay. Oops. That's not y squared, it's actually x squared. Okay, x squared is 3. Okay. Next, we're going to do the gamma 3. So this was the gamma 2 integral. Plus the integral gamma 3. That's going to be from 0 to 3 again. Now x times y. So x is 3 minus t times 1 times negative 1. Y for the derivative of x with respect to t, plus 1 squared times 0 for the derivative of y with respect to t, dt. So this is the gamma 3 integral, plus from 0 to 1. Here, x is going to be 0 times y. You, of course, don't have to put all this stuff in your answers. I'm just writing it because, I want to make sure I'm clear about what's going on. That's y squared here. So this is x times y dx dt. This is the y keep forgetting it's x squared. Times 1 for the dy dt. And actually negative 1, but it's not going to matter because it's going to be 0 anyways. Okay. All right. I don't have to do all these integrals, okay? This one's clearly going to be 0. This one's clearly going to be 0. Okay, so doing this integral, we're going to get this integral, we're going to get the integral from 0 to 1 of 9 dt, plus the integral from 0 to 3 of t minus 3 dt. I'm just switching the order because of the negative 1. So I'm going to get 9t plus t squared over 2 minus 3t from, man, I suck today. It must be Monday. You guys are like, no, it's every day. And I'm like, say that to my face. And you're like, I will, and whatever. Okay, it's all fun and games, and then my feelings got hurt. And if you're still listening to this, then you're either laughing or like, just give it up, man. Okay, and you get 9/2. Okay, so that was the really long, convoluted way to do this. What was the point? Just to show you that that's the answer. Let's retake our integral again. Let me rewrite it. And we're going to do this by Green's theorem now. Okay, the integral over the curve of xy dx plus x squared dy equals. Now, this is P and this is Q. And remember, we're doing it over this rectangle. One, two, three, one. Okay, so remember, this is going to be the integral x goes from 0 to 3, y goes from 0 to 1, of partial q with respect to y minus partial p with respect to x, dy dx. Okay, let's see. So that's going to be the integral from 0 to 3, from 0 to 1, partial q with respect to y. I'm sorry, partial q. Why do I always mix that up? It should be partial q with respect to x minus partial p with respect to y. So partial q with respect to x is 2x. Partial p with respect to y is x. Okay. All right, and if you do that integral out, which isn't too hard, it's going to be 9/2. Okay. All right, so that was Green's theorem.